today's kind of an exciting day for me. I've been working on an update to Storm. So Storm is a file synchronization app that I built back in 2016. It was first released, and since then it's been running the whole time. Yeah, it's been running and been reliable in synchronizing files. But technology's moved forward. Things are capable of being a lot faster than they were. Plus, I'm a better developer than I was when I first built it. So I really wanted to go back and make Storm to be better and be more up to date. Just a higher quality software in general. And so I've taken some time recently to add some technology that will make file synchronization much faster and actually be a little bit cheaper for me to run, and hopefully more reliable and more secure, and all of those things. So I've put in a lot of work in the last 2 weeks, to update it and make it better. Now there's still some work to do, but this is my first attempt to completely switch over to the new synchronization system. And so we're going to try it, and it might break, right? I fully expect it to break, actually, because, of course, I haven't even tested it. But I want to try it with a large file and see how fast, or if it works, but how fast we can get this file synchronized over, and if all of the encryption and decryption, encryption on the side that's sending it and the decryption on the side that's receiving it, if it's all working. Hopefully, because I've tested every piece along the way, hopefully it'll work great. But integrating everything together potentially, can end up broken. You never know, unless you have good tests written. So write your tests. But let me go ahead and switch over to a screen here. So, all right, this is the computer that's going to be sending the. So this is the file that I'm going to be sending. It's a beautiful 4K video of from one of the days that I just flew my quadcopter over my neighborhood, and so we're going to take this video. It's just under 2 gigs. And we're going to put it into the Storm folder, and we're going to watch it synchronize over to the other computer as it does that. So we're going to go ahead, and I'm going to close that, and we got to start up the app. And when you're using Storm, the app is all automatic, but because this is a development version, I have to run it by hand. So we'll go ahead and run that. I have not turned it on this computer, so it's gonna do a lot of initialization, and you'll be able to see that on the video. Oh no, an uncaught exception. I knew things would break, so that sucks. Okay, let's go ahead and fix this. I know exactly how to fix this problem. So I didn't put the -s when I said save and didn't commit it, so that's unfortunate. So we're gonna go ahead and install that, and you'll see it come in. All right, let's try it again, huh? You never know, it's anticlimactic and then it's not. So start it up, see what other bugs happen. Okay, all right, so we got some initialization. It's gonna ask for access on stuff, and yet we're using IPFS on the back end, which we weren't doing previously. And this is now a large amount of logs. You can see that it's initializing, and of course, in the shower, you think, oh, I could totally make this better. So in the development version right now, I've gone and I've added every single file in Storm folder right to IPFS. But I don't think that's the way to do it. I don't think that's the way we need to do it. I think what we can do is take, I already have a synchronization algorithm in place, right? So we have a way for each computer to talk to each other and say, hey, here's all the files that I have. What are the files that you have? And they compare. And what it uses is a hash of the database itself. It says all of these hashes put together, it's with single hash. And if each computer has the same hash, then it doesn't have to synchronize anything. But if it's synchronized, or if it's out of sync, then each computer is going to have either a different hash or an older hash. And so what it does is it will then compare the most recently changed files, and it'll just go back in time until it finds the file that it's missing. And it will then make a request to that individual computer, that client, we call them clients. So it'll make a request to that client, and then it will download just that file. Now, right now in the dev version, as you can see, I'm just getting tons of logs because in my test folder, there's about 3,000 files. Now because we read every single file, it's saying them all changed. Yeah, so there's a few things that I think we need to improve. That communication protocol, it just asks for the single file that's missing. And so if I can go and just put into IPFS the single file that needs to be sent, that's what I'm going to do. And so instead of loading them all into IPFS, which would be really lame because then it's all your files being there permanently up on IPFS, you never know who downloaded your file. That's just really lame for private files and whatnot. Now, I haven't mentioned all of these are end-to-end encrypted. So when a file is being sent to another computer, it will encrypt it into a file that's only readable it's only readable if you have the password and initialization vector. So those two things combined makes it so you can read the file. And those things are sent privately, end-to-end encrypted, using Storm's sockets, TCP connections. So I'm getting really technical and into the weeds here, but I'm kind of excited about this. I'm explaining it all because I've been fascinated by it for years. So anyway, as you can see, I'm still adding more and more files to IPFS as it reads and goes. I don't have down here on my other computer that's going to be receiving the file. I'm not running anything yet. It's not even gonna connect until I see that these logs have settled down and they're gonna stop sending messages here. So here, and you can see my other computer. So this is the computer that will be sending things. It's a desktop computer, and then down here is my laptop, and they'll be connected through Storm's web sockets. We'll go up and down to Storm, and that's how we route traffic and have the desktop clients communicate to each other. And then when they're sending files, the old system would send through that same web socket, and then the web socket would then send the message to the right computer. Whoever was talking to each other, we kept track of that, and it acted as a router. And that system was great. As you can tell, there's a lot of things that are lame about that system. One, scalability. Single point of failure is another one. And it gets expensive having traffic go in and out of Amazon Web Services or whoever your host is. I don't really want to be the router for all of these things if it makes more sense to have the computers connect directly to themselves. The original design of Storm, let's see. So the original design of Storm was to have all the computers that are networked together to actually find each other on the network. Let's see, it was designed to find each other on the network so that they could just message each other directly. And there's a lot of mechanisms that we built in to be able to do that, things like RSA private and public keys. So we would use the public key to encrypt the message just for the client that is supposed to receive that message. You have to do kind of a three-legged thing that says, hey, this client is logged in with this user, and then you get an approval from Storm that says, okay, I verified this user, and so another client that's connected also has to be logged in with that user, because you don't want another user to come in and say, hey, I'm going to connect to your computer and I'm going to get all your files. You don't want that. You want to be protected, and you want somebody to validate that for you. There are ways and protocols for validating what computer you're sending stuff to and whatnot, but we chose this way because we knew it was something that we could control and that we could depend on, so that our customers could be confident in the way that the clients are connecting to each other. So anyway, back to the test. I'm super excited to see how this stuff works out, and it looks like our logs have slowed down. So we're going to go ahead and clear the logs here, and we're going to jump down to my other computer, which I'm recording in 2 different spots, so we'll have to connect these and you'll see it separately. So I'm going to go ahead and start it. Maybe. There it goes. Running. Okay. All right. So we got the client running here, and normal usage of this will not. Normal usage of this app is actually not going to. You're not going to see these logs. These are just logs for development purposes. Okay. All right. So as you can see, I've got a different desktop, right? So I've got 3 computers on this network. I have one on the old version that's only going to do the file synchronization going up through a server, through the Storm server and back down to our computers. So that's live PC, and then we should be able to see a Frostbeard connection. Yeah. So hello from Frostbeard. And you can see that the local version of my database starts with 837E. That's a good hash. And then the remote, which is Frostbeard, that one has 837E. And then you can see, looks like Frostbeard is going through and unpinning a bunch of files that it doesn't need, apparently. I hope that that's not bad. Okay, all right. Well, okay, so we do have a big synchronization thing that goes through, and anything that isn't part of or isn't stored in the database, I unpin, right? So if I don't have it in the database, then I unpin it. And it looks like there were stuff pinned. I don't know why it would be doing that. Cool. All right, so we pruned some stuff. I don't know. We can check out the IPFS. Do I want to do that? We could. Let's see. I have a lot of tabs. Don't judge me. Okay, so if we go to 501, I think I set up the gateway to run on 502. Yep. Web UI, or is it Web GUI? I don't know what it is. You'll probably see it down here on this other computer as well. So, yeah, 501 Web UI. 5001 Web UI. There we go. All right, so we got an IPFS host running, and it looks like we're hosting 4.5 gigabytes of data, which is more than I would expect it to be hosting, to be honest. 4.5. We can check the other computer here. Yes, I got more tabs. 4.9. Interesting. And we got fewer peers, which is also interesting. Anyway, so we weren't at 4.9 before, so looks like we'll have another bug that we'll need to debug. We're going to go ahead and we're going to watch the status on each one of these. And I'll bring this so we can so I can monitor the status, and when it starts showing something interesting, I'll switch over to that screen. Okay, but now I want to start dropping this file in and seeing what it does. So this quadcopter video, we're going to drop into the Storm folder, and then we'll probably see some events over here that says, oh, file is changed or created, and it's going to create a checksum and send a message over the WebSockets to the other machines. So on the other computer here, we'll be able to see a new message come in that says, oh, Frostbeard created a new file. And so then our computer, knowing that it doesn't have that file, it will request that file. So clear the logs. Let's go ahead and see what happens. All right, moving to the Storm folder. Here we go. Okay, event triggered. Okay, it's reading it. Okay, file has changed. DJI 0114 MP4. And that's an event that it should send out to the other hosts. Okay, one updated in the database. I've got a bunch of events coming over here, and we can tell that our local and remote databases are different. And now we're checking the whole database for the next file because, of course, we don't know, and it's queued up. Use IPFS is not a function. Should be. I think I messed up the config. Pretty sure I did. So we can open up our diagnostics. If it is downloading the file over the web sockets, we'll see it in diagnostics because I've mapped that up. If it's downloading over IPFS, it won't show up in that diagnostics folder. It probably, because I hit this error, it's probably not gonna do it. Okay, all right. So let's kill it. I'm gonna go ahead and move this DJI out of the file. It will probably say, hey, file deleted. And it should resynchronize. Yep, file doesn't exist, that's fine. Okay. Alright, a couple bugs, but that's fine. So our databases should be in sync. So if we look at the diagnostics thing, it should say libpc and Frostbeard are back in sync. Alright, so there was a bug. Let's see. We'll find config.use IPFS is not a function because, oh, come on, did I go there? It's not a function, dummy. All right, use IPFS is a function here on util. Of course. So anywhere we say config.use IPFS was wrong. Oh, come on. This should be util. Let's find the other spot that we did that. Now, the reason I have to point it at util is the util file is where I have the connection to the config, right? So it reads the config every time we check it. And use IPFS is a user setting. So if, let's say, if you didn't want to put your files onto IPFS for fast transfer, you could turn that off, and then it would go back to using the old WebSocket connection. It's very slow synchronization, but it is reliable and it works. Just don't expect it to be super quick compared to using IPFS. So, all right, we're gonna go ahead and save this. Save those changes. We're gonna go ahead and commit them. Just make sure we're not adding something else that we didn't expect. Okay. Fix preference check. All right, okay, we're pushing up those changes, and we'll go ahead and pull those changes on the other machine, which should fix it, and we should be able to run it again. There we are, we're running. Started the swarm, and our databases are equal. Go ahead and run it on the other machine. And started up our IPFS daemon. Databases are equal. Okay, clearing those logs, switching over to the folder, make it so we can get to play some window games here. Okay, all right, DJI into the Storm folder and watch for some events to happen. Okay, there is a debounce on the event triggered because I found that if you drag and drop 100,000 files, there's going to be 100,000 events triggered, and it just doesn't make any sense to have that many events handled if you can just batch them within a few seconds. All right, one new file. Q. Right, should we check the IPFS? Looks like out. Let's show that. Our out is sending at 19 megabytes per second. Looks like we're receiving at 19-ish, 16 megabytes per second. Oh, this is exciting. All right, we can remove that so you can see it. Still 13 megabytes. I'll expect to see these kind of come together. Move over there. Incoming and outgoing. See, so these files are being sent over IPFS peer-to-peer instead of up and through my server. One thing that I found is, if, let's say you're trying to synchronize with your machine at work, right? So you're at an office with high-speed internet, and then you're at your house where you have, maximum of 40 megabit up. Then what happens is one computer can't upload fast enough, and you end up going through my server, which has a bottleneck as well, and it's just less speedy. So two machines on the same network connected through gigabit connection are gonna have high-speed file transfer between each other, where even if you were on the same network at home, you would still on the old service. If you were to be on the same network, you'd still have to go out and back using the old connection. So this should be a lot faster on local machines, or on between two fast networks. It'll be a lot faster. There won't be such a bottleneck as there was. Okay, it looks like the outgoing has slowed, and the incoming has slowed too. Let's look at the logs on the machine that received. Got the path, the size, the checksum, IPFS hash, and hidden is the password. All right. So it's say okay. Now that we've downloaded it from IPFS, we copied it or downloaded it. It finished. Whew! A lot of events are being triggered. You never know what's going on. You know, it's the first time for everything. First time getting this to work. So I hope we don't sit there with that many events triggered. That's kind of freaky. It might be because it's copying that file still. Let's go ahead and that's annoyingly big. Let's see. Go to the Storm folder. I see a DJI. Oh man, we already have that file. Let's see if we get a message that says our databases are equal. Yep, Megamind, which is the laptop up here, I can see that our databases and the local machine are equal. And I have the file. Let's see if we can play it. Oh man, it's beautiful. Oh, this is cool. Okay, this file is synchronized over IPFS using the Storm communication protocol. Oh, this is cool. That makes me so happy. All right. Okay, so a few things that are left for me to do are I need to pipe through all of the user settings and say, if it's something that the user wants, you can turn on and off IPFS, and then we'll go through and see if we can avoid putting all the files onto IPFS and just put the ones on that get requested. I think I'm going to experiment with that, but I think that would be a preferable thing than having all of your files, even though they're encrypted. I don't want them sitting on IPFS wide open for anybody to download. So we're going to remove them from IPFS and only put the ones on IPFS that should be there. And then then we'll go ahead and clean. Let's see. Yeah, you can remove them once they've been transferred. So if all the clients are in sync, then you can go ahead and just remove them from IPFS. That way we don't duplicate the storage on your machine. We only duplicate the file that's being sent. And then once it's done being sent, it removes itself. So that is one drawback of this IPFS is if you're going to send a file, we encrypt it and save it to a hard drive, and then we can send it to IPFS, which is another duplication that sends it up, and then we clear it from the temporary encrypted copy. We remove that from the temporary folder, and so potentially you would have 3 copies of the file when it's being sent. You'd have the original unencrypted version in the folder where you're using it and working with it, and then it would copy, and you'd have the encrypted version that IPFS reads into its own database and sends, and then and when you receive it, you'd get it from IPFS. It would store it in its cache, in IPFS's cache, copy it into the temporary folder in a form that Storm can read, and then it would stream it back into the working folder of Storm in an unencrypted, where we decrypt it from temporary. It's stored as an encrypted file, and then Storm folder is unencrypted. So the temporary piece needs to be read and decrypted and placed back into Storm. So you have 3 copies on each machine, which is ridiculous. And so we want to minimize that for when sending and receiving files. One nice thing about the old system was we could read the file right from the working directory, stream it into memory, and encrypt it and send it without ever writing it to disk. And so we didn't duplicate space on the disk for facilitating transfer. And so that's one drawback of using the IPFS version of Storm, is you'll duplicate the file. And when I release this, I think I have a way and planned out where we don't have to always store copies of the entire working directory. I think we can just store copies of the single file. So that'll be a drawback, but for the speed, you saw how long it took to transfer that file. That was pretty darn cool. So anyway, thanks for joining me for a little experiment, and we'll see you next time.